Hello, everyone, and welcome to this last of this series where we will be discussing some of the key insights that we have been seeing during the IDC's Manufacturing Summit with a number of SAS experts. My name is Marta Muñoz, and I lead IDC Europe's Internet of Things practice. Today with me, I have Brian Saunders. Brian is Head of Industry Consulting for IoT at SAS. Welcome, Brian. Great to have you with us today.
Thank you, Marta. I appreciate you having me.
Great. So, Brian, let me perhaps start with some data, some numbers. According to IDC own data, around 30% of IoT projects in manufacturing have already been deployed across multiple departments. Although this is promising, this is also a demonstration that there is a lot of work to be done to enable scalability and replicability of these IoT and AI projects across manufacturing organizations. Now, the good news being that our most recent survey across IoT decision makers in Europe also points out to the fact that 60% of manufacturing organizations in Europe are already planning to use artificial intelligence in their IoT projects. And one very interesting application across manufacturing organizations is the deployment of digital twins. So that's what we are going to talk about in a bit more detail during today's podcast. So perhaps my first question for you, Brian, is, from your own experience with the customers you've been working with, what would you recommend to manufacturing organizations considering the implementation of artificial intelligence and IoT projects such as digital twins for the first time? What do you think are the key steps and the initial requirements that they may need to consider when entering this area?
I think in manufacturing, certainly we see a big shift to utilize kind of AI and IoT as that catalyst for innovation, because it's these connected devices or things that are really providing that underlying data that is really now unlocking the true potential of what the AI technologies have promised for years. We now have the information and the data to kind of facilitate that. A few things that I would consider, just sort of areas where I see people get stuck along the way in this journey. The first is just a realization that IoT is about more than connecting devices and collecting data. It's really about what you plan to do with that data. How do you plan to utilize it to transform your industry, your operations? And that really comes back to a more comprehensive analytic lifecycle, not just the data acquisition piece. The second is just the realization that analytics is a team sport. So as you embark on these projects, make sure you have the appropriate representation from across your enterprise. These includes individuals from your business, IT, any data science communities, et cetera. Really trying to bridge that IT-OT divide that sometimes gets in the way of these programs. And then most importantly, I think just keep the end in mind. Don't lose sight of what the objectives are, but really don't underestimate the effort to operationalize the results as well. It's more than just creating an algorithm. It's about how do you embed that back into a business process. And then the fourth item that really sticks in my mind is really start small. Don't try to take on everything for a first project. Use those small wins to provide immediate value back to your enterprise. And that really, I think, is that catalyst for fueling those new investments to really extend and take those next steps. In terms of kind of the process, I think it's fairly straightforward. But as I see it, it's, again, kind of going back to that keep the end in mind. Start with your business goal. What outcome do you hope to achieve? This is critically important for manufacturers. That may be predictive maintenance, that may be process optimization, that could be supply chain enhancements. But again, think about what you're trying to achieve. Once you kind of have a vision, it really comes down to performing that data audit. Do you have access to the data you need to solve the current problem? And if not, that may require some new investments, new instrumentation. In many cases for manufacturing, they're usually data rich. So I think in most of the programs I've seen, they have a good foundation to start from. But where it sometimes falls flat is really connecting those IoT data streams to those other enterprise data systems that are required to build out that full comprehensive solutions. The next thing to consider is think about, where do I need to operationalize or execute these analytics? Is this on the edge? Is this in the cloud? Is this both? I think it's important to think of that early, because that will certainly influence some of the data systems that you need to consider for your analytic process. It thinks about any technology requirements or investments that may be required. And I think certainly based on studies that are out in the market today, we see a pretty significant shift to move to edge processing for a lot of these IoT applications. It's just a more efficient way of doing the pre-processing, lowering transmission and storage cost, and oftentimes it's now unlocking new value streams that weren't possible, with traditional cloud-based processing alone. So again, think about where that deployment needs to happen. The next phase is really that investigation and discovery. Once you kind of know what you want to go after, you've assessed that you have relevant data to support it, moving into that analytic journey. And this is important to support model development and validation. But the systems that you implement, going back to the team sport comment, they need to have a platform that really caters to the personas and the skill sets that you hope to be a part of this process. And then the last piece is deployment. Really, more than just deploying the algorithm, it's how do you tie the outputs of that algorithm back into a business process flow to really drive that intended action and outcome. And again, that last mile of that journey, getting the analytic to run is the first hurdle, but tying that back into your business process, that's where I see a lot of misses that are occurring today. But I think those barriers are certainly getting smaller and smaller as each day passes.
That's excellent. Thank you, Brian. Quite a number of things to take into consideration for these organizations, but I guess all equally crucial to make sure that there is a successful implementation in the end, and that the company can actually accrue some of those benefits that they're seeking for. And I guess, talking about benefits, in your experience, what are the key benefits associated to the use of artificial intelligence and IoT and digital twins as well for the companies? What are they seeking to obtain in your experience?
Yeah, I think certainly deployment of digital twins are becoming more pervasive, and certainly providing that foundation for those new value offerings that we talked about. And I think it would be tough in the context of a short podcast to cover them all, but at a high level, I'll just put them in a few key buckets or areas in which I'm seeing really the investments and really the payback coming from those investments. First is around predictive maintenance. And I think because it's a smaller constrained entity, I think organizations are now really starting there, because it's probably the easiest to get their hands around, where for those critical assets that drive their business processes, they can use digital twins to identify imminent risk that can lead to an equipment breakdown that interrupts their process flows and ultimately drives very costly repair. So I think that's kind of one category of application of digital twins that I think is very pervasive and certainly showing pretty significant returns. Extending on that sort of concept, many manufacturers or equipment OEMs are instrumenting their field assets to really drive improved serviceability. And with that intelligence, it's providing a very valuable feedback loop to give those real world insights around how assets are actually utilized in the field, which I think is driving accelerated innovation around product design. So building better products for their customers for the intended function. So I think those two sort of parallel one another. The third key area is really around optimize operations. This is where you're sort of moving beyond a single asset into more connected processes. But by understanding those complex interactions, organizations now are having that insight to make real-time adjustments to optimize the output of a production process. Maybe that's finished good quality as an example for a manufacturer, but controlling the individual process settings along the way to maximize the output or quality of the output. The fourth area, which I think sort of extends on that optimize operations, there's a real opportunity to position and design more efficient processes for organizations, not just making what you have work, but designing it better for the future. The challenge or the headwind that I see there for these sort of efficient process designs is there's really no consistent standards today to ensure interoperability. So I think that's still a bit of a headwind that some organizations are facing, but certainly we have seen some successes where they've been able to see some realized benefits in that space as well.
Excellent. Thank you. Thanks for that, Brian. And of course, all of these can also have applications for companies who might be seeking to become more sustainable organizations, reducing, for example, their waste and carbon footprints and so on. Actually, some of these use cases, such as the ability to analyze and monitor energy efficiency and so on, can have some serious implications for manufacturers in particular. I wonder if you can give us some examples of implementations that you've run for some of your manufacturing customers, and perhaps even if you want some specifically focused around their sustainability objectives.
Sure. Yeah, I think manufacturing is sustainability. I think is pretty key across many industries. Specifically in manufacturing, we're seeing some high energy utilization processes, for example, like steel production, where they are relying on digital twins to drive simulations prior to runs of a production process to really figure out how to optimize the overall energy demands, given the current conditions, as a way of sort of reducing their overall cost and certainly drain on the power systems that feed them. It's kind of extended to that. We've actually worked with another manufacturer that creates building products, and they used a digital twin of their material movement system to look at the flow of wallboard or drywall throughout their process, really to identify areas that would create bottlenecks or jams that could lead to damage of product. And that doesn't necessarily seem like a sustainability goal, but as you think through, as this product gets damaged, the gypsum can actually be recycled, which is a good thing. The downside to that is it is a very costly process in terms of energy demands. So for them, they used a system of sensing and computer vision capabilities to monitor that flow, again, as a way of predicting events that could cause damage that would lead to that recycling, which then drives up their energy consumption for the markets. And certainly beyond manufacturing, we also see it. My background is more in the electric utility space, where we worked on modeling combustion systems in an effort to minimize carbon emissions and reduce overall fuel consumption to meet that sort of critical power demand for cities and beyond. And then, certainly sustainability hits pretty close to home for my company at SAS at our headquarters. We have implemented a smart campus initiative really across our entire campus, where we have full building automation systems to look at HVAC, heating and cooling performance, understanding how we can better optimize that usage to lower demand. And then we augment that power requirement with a solar farm that we have on site. And there we monitor our actual power generated versus the expected power given current environmental conditions as a way of ensuring that we are augmenting as much of the power requirement as possible using renewable sources. And again, trying to lower that overall demand through better monitoring and services across our very complex system of buildings, if you've ever been to the SAS campus.
Yeah, that is really fascinating. Thanks for that, Brian. And thank you for sharing some of these examples, especially at a time when we see sustainability becoming a key priority area for many senior executives across Europe in particular. So I think those are particularly relevant now. Now, to summarize, think about analytics lifestyle, about the need to have appropriate representation from all parts of the organization. There's also the need to keep the end in mind, but not to underestimate the effort. And one of the other recommendations you mentioned as well was to start small, really, as some of the points to remember when deploying these type of projects in manufacturing. Actually, they're great recommendations for companies who are looking at implementing digital twins or artificial intelligence and IoT in combination, wondering what these can do for their businesses. So thank you very much for that, Brian. And sadly, this takes us to the end of our time. So thank you very much, Brian, for your time with us today. It's been great having you here.
Thank you for having me.
And for those of you interested in learning more about the importance of artificial intelligence and IoT in manufacturing, please do listen to our other episodes in these mini-series regarding AI and IoT with SAS. Thank you very much for listening, and that's goodbye from me.